Hello, this is BPLab. Today, we will use Scratch to create a wooden piano that can be actually played. When you touch the wooden piano, an electrical signal is sent to the computer, and the sound of piano keys will be produced. So, let's get started. Here's the list of materials to make a wooden piano. Piano frame, Makey board, USB cable, alligator clips, jumper wires, and finally, copper tape. Then, let's start making it. First, let's start by making a conductive wooden piano. Cut the copper tape into 8 pieces, making sure to cut them longer than the length of the keys. The length of each tape should be around 8 to 9 centimeters, enough to cover the top of each key with copper tape. Attach the tape one by one to the remaining 7 keys using the same method. Please be careful not to break or overlap the tape, as it may prevent the sound from being produced. Once you have attached all the tapes, the exterior of the piano is complete. Now, we will connect the piano to the computer and make the piano sound. We are going to connect the piano to the computer to make sound. We will use the wooden piano model, Makey board, USB cable, 9 alligator clips, and 6 jumper wires to create sound on the piano. First, we will connect the power to the Makey board. Connect one end of the USB cable to the computer, and the other end to the Makey board. When the lights flash, it indicates that the connection is successful. Connect the bottom part of the Makey board called earth to the alligator clip. Connect jumper wires to the 6 input terminals, one that will be in charge of the piano keyboard. For the seat and a high deuce sounds of the piano keyboard, connect 2 alligator clips to the left and right of input terminal 2, one by one. Connect the jumper wires and 6 alligator clips. After connecting the wooden piano frame and the alligator clip, the electronic piano is complete. From now on, we are going to use Scratch 3 to code the wooden piano so that it makes a sound when you touch it. First, access the Scratch site. When the page opens, click Create. Click the Sound tab. Removes the meow sound in the menu. Press the sound-shaped icon button at the bottom and click Choose a Sound. Search for piano and add the sound C piano. Check if C piano is added to the sound menu. Add other piano sounds in the same way. Add D piano through C2 piano. After importing all the piano sounds, click the Code tab again. Click the Event menu and import the, when the space key is pressed, block. Change space to W to match the piano you made. And, click the Sound menu again. Get the C piano sound block. In the same way, import and code the block as shown in the image below. Coding is all done. Now, hold the crocodile clip connected to earth with one hand, try playing the piano with your other hand. So far, we've made a piano, put sounds on it, and even played it. You can play a variety of musical instruments using Scratch. I'll look for you with another instrument next time. Hello, this is BPLab. Today, we will use Scratch to create a wooden piano that can be actually played. When you touch the wooden piano, an electrical signal is sent to the computer, and the sound of piano keys will be produced. So, let's get started. Here's the list of materials to make a wooden piano. Piano frame, wood glue, makey board, USB cable, alligator clips, jumper wires, and finally, copper tape. Then, let's start making it. First, let's make a wooden piano that conducts electricity. Take out both piano frames. The wider side is the bottom plate of the piano, and the side with the keyboard model is the top plate of the piano. Cut the copper tape into a total of 8 pieces according to the number of keys. Attach enough copper tape to cover the height of the bottom of the piano. Apply wood glue to both sides of the piano top plate and attach it to the piano bottom plate. Once everything is attached, the appearance of the wooden piano is complete. Now, let's connect the piano and computer with the makey board to make piano sounds. We are going to connect the piano to the computer to make sound. We will use the wooden piano model, makey board, USB cable, 9 alligator clips, and 6 jumper wires to create sound on the piano. First, we will connect the power to the makey board. Connect one end of the USB cable to the computer and the other end to the makey board. When the lights flash, it indicates that the connection is successful. Connect the bottom part of the makey board called earth to the alligator clip. Connect jumper wires to the 6 input terminals, one that will be in charge of the piano keyboard. For the C and a high deuce sounds of the piano keyboard, connect 2 alligator clips to the left and right of input terminal 2, one by one. Connect the jumper wires and 6 alligator clips. After connecting the wooden piano frame and the alligator clip, the electronic piano is complete. From now on, we are going to use Scratch 3 to code the wooden piano so that it makes a sound when you touch it. First, access the Scratch site. When the page opens, click Create. Click the Sound tab. Removes the meow sound in the menu. Press the sound-shaped icon button at the bottom and click Choose a sound. Search for a piano and add the sound C piano. Check if a C piano is added to the sound menu. Add other piano sounds in the same way. Add D piano through C2 piano. After importing all the piano sounds, click the Code tab again. Click the Event menu and import the, when the space key is pressed, block. Change space to W to match the piano you made. And, click the Sound menu again. Get the Start Sound C piano block. Let's code other keys in the same way. Right-click the mouse and click Duplicate to copy. When ES key pressed, start sound D piano. When S key pressed, start sound E piano. When D key pressed, start sound F piano. When F key pressed, start sound G piano. When IG key pressed, start sound A piano. When right arrow key pressed, start sound B piano. When left arrow key pressed, start sound C2 piano. Coding is complete when you complete 8 blocks like the screen. Hold the alligator clip connected to the earth with one hand. Try playing the piano with your opposite hand. So far, we've made a piano, put sounds on it, and even played it. You can play a variety of musical instruments using Scratch. I'll look for you with another instrument next time. Hello, this is BPLab. Last time we made a playable wooden piano using Scratch. Today, we will use Scratch to create a wooden drum that can be actually played. So, how can we make these wooden drums sound like real drums? That is, using the properties of a conductor to send an electrical signal to a computer. By attaching a conductive material to the drum, if the drum is touched by the hand, an electrical signal is sent to the computer, and a drum sound is generated according to the signal. So, as a first step, let's make a conductive wooden drum. Here's the list of materials to make a wooden drum. Drum frame, Makey board, USB mini 5-pin cable, wood glue, alligator clips, jumper wires, copper tape, and aluminum tape. Wood glue can also be replaced with double-sided tape or a hot glue gun. First, take off all the drum shapes from the wooden frame. The large circle in the middle is the bass drum of the drums. And from the left, hi-hat, snare drum, low tom, and crush cymbal. Cut aluminum tape larger than the size of the drum and wrap it around it. And we're going to create a path for the signal to be sent from the drum to the computer. Cut the copper tape into 5 pieces of appropriate length. Enough to cover the height of the drum. Attach the copper tape to the drum frame. Apply wood glue to attach the drum model wrapped in aluminum tape to the frame. If you attach all the frames, the electric drum is complete. Then, let's connect the drums and the computer using the Makey board. Now, let's connect the drums and the computer so that they can make sounds. The Makey board converts drum touches into signals and transmits them to the computer. First, plug the USB cable into the computer and connect the Makey board to the other end of the USB cable. A blinking light on the board indicates a successful connection. Attach an alligator clip to the earth at the bottom of the Makey board. Plug the jumper wires into the left side of the board that will be responsible for the 5 sounds of the drum. Connect jumper wires and alligator clips. And connect wooden drums and alligator clips. Electronic drum is complete. Then, let's program the drum sound to match the touches. Before programming, you will need a scratch file with drum sounds. The file can be saved by accessing the website and then clicking the download button on the drum sound code. So let's start programming. Access the site to get started with Scratch. When the page opens, click Create. In this File menu, click Load from your computer. Click the downloaded project file to open the project. Click on the Sounds tab to make sure all 5 drum sounds are included. Click the Code tab. Click the Events tab, and get the When Space Key Pressed block. To change the input to fit the bass drum, change Space to EW. Click on the Sound tab. Get the Start Sound Bass Drum block. Program the rest of the drums in the same way. When you complete the 5 blocks as shown on the screen, the drum programming is complete. So, shall we play the drums? Let's hold the alligator clip connected to earth with one hand and play the drum with the other hand. So far, we've made electronic drums, programmed sounds, and even played them. With Scratch, you can create and play a variety of musical instruments, such as a piano or xylophone. Then, next time, I'll see you all with a different instrument. Hello, this is BPLab. Today, we will use a Scratch to create a wooden drum that can be actually played. First, let's learn about the structure of the drum. The 2 trapezoidal shapes on the left are hi-hat and open hi-hat. The small circles at the top of the drum are high tom and a low tom. The 2 trapezoidal shapes on the right are the crash cymbal and ride cymbal. Finally, the large circles below the drums are the snare drum and the bass drum. Now, we will assemble the wooden drum, attach conductive tape, and connect it to the Makey board and program it, so that the drum makes a sound depending on where it touches. Here's the list of materials to make a wooden drum. 2 drum frames, wood glue, aluminum tape, copper tape, makey board, alligator clips, USB mini 5-pin cable, and jumper wires. First, get 2 wooden frames. The wider part of this frame becomes the bottom plate. The upper and lower parts become the sticks of the drum. The frame in the center of this frame is the drum parts. And the other frames are the pillars that connect the part that drum and the bottom plate. Then, take off all the drum parts from the wooden frame. We will use aluminum tape to conductively coat the instrument. Cut aluminum tape larger than the size of the drum and wrap it around it. Tape the remaining part of the tape to the back. Since the hole in the frame needs to be connected to a post, attach the hole on the back so that it is not covered with tape. Paste the rest in the same way. When attaching the aluminum tape to the rest of the area, attach it so that it overlaps enough with the first tape. Apply aluminum tape to all remaining frames. After all the aluminum tapes have been attached, the next step is to take off the bottom plate of the drum and the pillar's frame. Attach the pillar to the drum frame using wood glue. Start with the hi-hat on the far left of the drum. If you look at the pillars, you can see that the lengths on both sides are different. Insert the short side of the pillar into the short side of the hi-hat frame and fix it. Secure with wood glue. And point the shorter side of the pillar towards you. Fix it to the bottom plate of the drum with glue. The open hi-hat is also attached in the same way. When attaching high toms, low toms, crash cymbals, or ride cymbals, also make sure that the short side of the pillar faces you. Now we're going to attach the big circle frame as well. When attaching the large circle frame, we will attach the support to the base first. We will attach it to the base plate, so that the side perpendicular to the side of the support is facing down. Fix it with the short side of the support facing you. Attach the large circle frame with the side closest to the side where the hole was cut facing you. Attach the other round frame in the same way. Completed wooden drum with conductivity. In order to play the drums, the drumsticks also need to be conductive. Take off the drumstick frame. Assemble by crossing drumsticks of different shapes, then apply glue. Do the same for the rest of the drumstick frame. Attach copper tape to the drumstick to make it conductive. Cover everything from the position where you hold the stick to the part where you play the drum with copper tape. If the copper tape is torn along the way, peel it off and reapply it from scratch. Apply copper tape to the remaining drumsticks as well. A conductive drumstick is complete. So far, we have been making conductive drums and drumsticks. Then, let's connect the drums and the computer using the Makey board. We will use alligator clips and jumper wires to connect the drum to the Makey board. First, put alligator clips on the drum one by one. Then, plug the jumper wires into the left side of the Makey keyboard. W, A, S, D, F, G on the Makey board will be connected in order from the left side of the drum as shown on the screen. Connect the jumper wire, plugged into the W pin to the crocodile clip, connected to the hi-hat of the drum. When connecting, make sure to connect them in a straight line so that they don't come off easily. And then, connect A pin to open hi-hat, S pin to high tom, D pin to low tom, F pin to crash cymbal, G pin to ride cymbal. Connect the crocodile clip holding the snare drum to the up arrow on the Makey board. And, connect the crocodile clip holding the bass drum to the down arrow. Now let's connect the drumsticks and the Makey board using alligator clips. Clip the end of the drumstick with an alligator clip. Connect the other side of the alligator clip to the bottom part of the Makey board, earth. Now, drums and Makey boards are all connected. Now we're going to make it sound on the computer when we play the drums using the Makey board and scratch. First, connect the USB cable to the computer and plug the other end of the cable into the Makey board. If the light on the board flashes when you hit the drum with a drumstick, it indicates a successful connection. Now, let's use Scratch to program the drum sound when the electronic drum is hit. Before programming, you will need a Scratch file with drum sounds. The file can be saved by accessing the website and then clicking the download button on the drum sound code. So let's start programming. Access the site to get started with Scratch. When the page opens, click Create. In this File menu, click Load from your computer. Click the downloaded project file to open the project. Click on the Sounds tab to make sure all 8 drum sounds are included. Each drum sounds the same as the screen. Click the Code tab. Click the Events tab and get the When Space key pressed block. To change the input to fit the hi-hat, change space to EW. Click on the Sound tab. Get the Start Sound hi-hat block. Program the rest of the drums in the same way. Right-click on the block and click Duplicate. Set the sound of Open hi-hat to be played when the A key is pressed. In the same way, S key to play high tom, D key to play low tom, F key to crash cymbal, G key to ride cymbal, up arrow to snare drum, down arrow to play bass drum. When you complete the 8 blocks as shown on the screen, the drum programming is complete. Let's hold the drumsticks connected to earth and play the drum. If the light on the board blinks each time you hit the drums, it's working fine. So far, we've made electronic drums, programmed sounds, and even played them. With Scratch, you can create and play a variety of musical instruments. Then, next time, I'll see you all with a different instrument. Hello, this is BPLab. Last time, we made a playable piano and drums using Scratch. Today we will make a glockenspiel that makes a clear sound. We will attach aluminum tape to the wooden glockenspiel to make it conductive. After that, when the electrical signal from the glockenspiel is input to the computer, the glockenspiel makes a beautiful sound. Now, let's make a glockenspiel. Here's the list of materials to make a wooden glockenspiel. 2 glockenspiel frames, aluminum tape, copper tape, screwdriver, bolts and nuts, makey board, alligator clips, jumper wire, and USB cable. First, let's take out 2 glockenspiel frames. The first frame is the support of the instrument. The other side contains the keys and sticks of the glockenspiel. The longer the keyboard, the lower the sound. In order, the keys are low do, re, mi, fa, sol, la, si, high do. Please take off all frames. We will attach aluminum tape to the glockenspiel to make it conductive. Cut the tape to fit the length of the keyboard and attach it as shown in the video so that one side and height of the keyboard are covered with aluminum tape. Cover all keys with aluminum tape in the same way. Now, let's assemble the glockenspiel. On the longer side of the frame, a keyboard that produces the low do sound is placed. And on the shorter side, the keyboard that produces the high do sound is placed. Next is the stand part of the glockenspiel. Assemble the part with logo on the part that will make a low do sound. Insert the bolts into the holes in the frame and secure them with nuts. Insert the nut into the stand frame and insert the bolt into the hole. Tighten the bolt and nut with a screwdriver. Do the same on the other side. Now, fix the do, re, mi keyboard to the glockenspiel. Use a bolt to drill a hole in the key covered with aluminum tape. Insert the nut and tighten the bolt with a driver. Insert the FA key into the stand as shown on the screen. After drilling holes in the keyboard with bolts and assembling it on the support, turn the nut slightly onto the end of the bolt. Take the stand frame and fit it into the square hole of the keyboard support. Tighten the stand with a screwdriver. After placing the Sola keyboard, insert a nut into the gap in the stand frame and secure it with a bolt. Assemble the remaining la, si, high do keys with bolts and nuts. The exterior of the glockenspiel is complete. Now, let's make a glockenspiel stick. Assemble the 2 stick frames by crossing them. Attach copper tape to make the stick conductive. Cover the entire stick from the grip position to the end with copper tape. The conductive glockenspiel stick is complete. Now, let's connect the glockenspiel to the computer and make the sound come out. We will make a sound on the computer by playing the glockenspiel using the Makey board. First, connect the USB cable to the computer and plug the other end into the Makey board. If the light flashes, it means that the connection has been established properly. Attach the alligator clip to the earth at the bottom of the Makey board. Insert 6 jumper wires into the Makey board. To produce the Isia sound and the Hi-Do sound, connect 2 alligator clips, one to the left and one to the right. Connect the jumper wire and 6 alligator clips, and connect 8 alligator clips to the keys to connect the Makey board and glockenspiel. Attach the alligator clip connected to the earth to the stick of the glockenspiel. Now, the glockenspiel and Makey board are connected. Now, let's block code in Scratch to make a glockenspiel sound when played with a stick. First, access the Scratch site. When the page opens, click Create. Click the button at the bottom left of Scratch. Click in Music to bring up the Music tab. Click the Events tab and bring the When flag is clicked block to the screen. Click the Music tab and connect Set Instrument to Piano under the Event block. Change the piano into a marimba. In the Events tab, get the block when space key pressed. We will change the signal to fit the Makey board. Change space to EW. In the Musics tab, import the Play Note 60 for 0.25 beat block. Click on the number and select To Do. Program blocks for the remaining keys in the same way. Right-click on the block and click Duplicate. Key A matches the sound 62. Key S matches the sound 64. Key D matches the sound 65. Key F matches the sound 67. Key G matches the sound 69. Key right arrow matches the sound 71. Key left arrow matches the sound 72. Please complete the code block as shown on the screen. Click the green flag and the code will work. Let's grab the stick connected to earth and play the glockenspiel. So far we have made and played an electronic glockenspiel. Using Scratch, you can play a variety of musical instruments and even join in with your friends. I'll see you next time with another instrument. Hello, this is the BPLab. We will be assembling and coding a smart farm kit ourselves. In this session, we will be assembling the smart farm kit ourselves. And in the next session, we will connect the Arduino and sensors, install software, and upload the smart farm source code to the Arduino. Let's check the materials for the smart farm we will be making today. We will need 4 smart farm frames, an Arduino Uno board, a breadboard, a relay module, an LCD module, a plant growth LED, jumper wires, a Phillips screwdriver, bolts and nuts, and adhesive. First, let's take a look at the frames. Frames 1 through 8 are used to create the basic structure of the smart farm. And frame 9 is a fixed frame that can be used to connect multiple smart farms. Frame 10 is an extension part that can adjust the height of the smart farm according to the height of the plants. First, detach frame 1, which will be the top of the smart farm. We will attach the plant growth LED to the back of frame 1. Remove the sticker on the back of the plant growth LED and attach it to the back of frame 1. Insert the jumper wires of the plant growth LED through the holes on the back of frame 1. Now, let's attach the relay module to frame 1 using bolts and nuts. Place the module pins facing left on the part labeled a relay of frame 1. Insert bolts into the 3 designated holes, as shown, and secure them in place using nuts. Use a screwdriver to tighten them firmly. Next, we'll attach the Arduino and breadboard to frame 1. Secure the Arduino using bolts and nuts in the 3 slots provided. Peel off the sticker on the back of the breadboard and attach it to the frame, making sure the plus end, indicated by the red line, faces outward. Now, let's connect the red jumper wire from the plant growth LED to the NO pin of the relay module. Use a screwdriver to loosen the screw on the pin, insert the red jumper wire, and tighten the screw back firmly to hold the wire in place. This time, detach frame 2 and frame 8 from the front of the smart farm. Align the 4 holes on the back of frame 2 with the corresponding holes on frame 8. Next, flip the LCD module over so that the screen faces upwards and the text is in the correct orientation. Insert a bolt from the front of the LCD module and secure it with a nut on the back. Detach 4 male to female cables and connect them to the pins on the LCD module. Attach the frame with the sensors to the front frame, and take out the jumper wire connected to the LCD module through the groove on the sensor frame. Finally, detach frame 3 and assemble it according to the provided diagram. Next, please detach the frame 4 and frame 5 with the graphics. Frames 4 and 5 will serve as the top supports. Connect them from top to bottom, aligning the grooves and ensuring that the graphic side faces outward. If you want a stronger hold, you can use adhesive. Next, please detach frames 6 and 7, which will serve as the bottom supports. Assemble the frames by aligning the grooves. Frames 6 and 7 should be assembled without adhesive, as they will be extended according to the height of the plants. This completes the assembly of the basic version of the smart farm. Frame 10 is a height extension part, and frame 9 is a kit connector. As the plants grow taller, you can attach the frame 10 part to the smart farm legs, as shown on the screen, to extend the height. Also, frame 9 is a part for connecting to other smart farms. By connecting them, you can grow more plants together. So far, you have assembled the basic and extended versions of the smart farm. In the next session, we will connect various sensors and Arduino to the smart farm to bring light into it. This time, we will connect the Arduino and sensors attached to the smart farm from the previous session, and connect the smart farm to the computer to do coding. We will code to check the air temperature, humidity and soil moisture where the plants are growing through the LCD module attached to the front, and to give light to the plants using the plant growth LED according to the value of the light sensor. The following are the necessary items to connect Arduino and the sensors and to code for them. A pre-assembled smart farm, a soil moisture sensor, a temperature humidity sensor, a light sensor, jumper wires, USB cable and power cable. First, we will connect the Arduino to the breadboard. The plus and minus poles of the breadboard are connected vertically, while the rest are connected horizontally. So, if we plug the jumper wires or sensor pins into the breadboard and connect the cables to the connected lines, they will be connected to each terminal. Connect two male-to-male jumper wires to the GND and 5-volt pins of the Arduino board. Connect the other end of the wire connected to GND to the minus line of the breadboard, and connect the other end of the wire connected to 5-volt to the plus line of the breadboard. Next, we will connect the LCD module. The cable connected to GND on the LCD module should be connected to the minus line on the breadboard. The cable connected to VCC should be connected to the plus line on the breadboard. The cable connected to SDA should be connected to pin A4 on the Arduino. The cable connected to SCL should be connected to pin A5 on the Arduino. Next, let's connect the soil moisture sensor to the breadboard. The soil moisture sensor measures the amount of moisture in the soil by connecting its electrodes to the soil. One side of the soil moisture sensor board has plus-minus pins, and the other side has VCC, GND, DO, and AO pins. Insert female-to-female jumper wires into the plus-minus pins and connect the other end of the cable to the electrode. Then, connect the 4 pins vertically to the breadboard. Next, you need to separate the 3 male-to-male jumper wires and plug them into the lines connected to the VCC, GND, and AO pins of the soil moisture sensor. Connect the other ends of the wires connected to VCC to the plus line of the breadboard, GND to the minus line of the breadboard, and AO to the A0 pin of the Arduino. Now we will connect a light sensor that will detect light. The circular part of the light sensor will detect light, and the pins at the bottom are labeled minus, plus signal. Insert the pins of the light sensor vertically into the breadboard, making sure they don't overlap with the pins of the soil moisture sensor. Then, connect the sensor's pins with male-to-male jumper wires. Connect the S pin of the light sensor to the A1 pin of the Arduino, the plus pin to the plus line of the breadboard, and the minus pin to the minus line of the breadboard. Next, let's connect the temperature and humidity sensor to the Arduino using jumper wires. The pins on the sensor are plus, out, minus. Insert the temperature and humidity sensor vertically into the breadboard so that it does not overlap with other sensors, and connect each cable to the corresponding line using jumper wires. Connect the minus pin of the temperature and humidity sensor to the minus line on the breadboard, the opposite end of the cable connected to the middle pin to the 4th pin of the Arduino, and the line connected to the plus pin to the plus line on the breadboard. Finally, let's connect the relay module. The left pins of the relay module are labeled signal, plus, minus. Insert the male-female cables into all of the left pins of the relay module. Connect the other end of the cable connected to the S pin of the relay module to the Arduino's pin 3. The cable connected to the plus pin should be connected to the plus line of the breadboard, And the cable connected to the minus pin should be connected to the minus line of the breadboard. The right pins of the relay module are labeled NC, COM, and O. Do not connect anything to the NC pin. Connect a male cable to the COM pin. Use a driver to loosen the bolt, insert the male end of the cable into the COM pin, and then tighten the bolt again. Connect the other end of the cable connected to the COM pin to the Arduino's VIN pin. Remember the red jumper wire we connected to the NO pin for the grow light LED? Connect the black jumper wire of the grow light to the GND pin of the Arduino board. If you've done all of this, the circuit is complete. Now, let's download the software to use Arduino. Search for Arduino and click on the top link to access the official Arduino website. If you don't see the official website, type arduino.cc in the address bar to access it. Click on Software at the top to go to the download page. On the right side, download the program that matches your computer's operating system. Click Just Downloads and run the installation file. Click Agree, then Next, Install, and Close to complete the installation. Next, let's install the extension board driver to use the Arduino Uno board. Open the Chrome browser and enter the address that appears on the screen to access the Smart Farm page. Scroll down to the bottom of the page under Arduino Smart Farm Download and download the first extension file. Click Install to install the Arduino extension driver. When a pop-up window appears like the one on the screen, the installation is complete. Next, let's download the Smart Farm source code and library files. Go back to the Smart Farm page and download the remaining 4 files. The second file is the Smart Farm source code. The third file is the temperature and humidity sensor library. The fourth file is the special character library. And the fifth file is the I2C LCD library. For the library files that are in .zip format, do not extract them. Click on the downloaded smartfarm.ino file, and if prompted, click OK. Once the Arduino program opens, we can now upload the Smart Farm source code to the Arduino Uno board. First, connect the USB cable to your computer and connect the other end to the Arduino board. When the board lights up, it means it's connected properly. Once you've connected the Arduino to your computer, let's check the USB port number it's connected to. Open the control panel and click on Devices and Printers. Check the USB port number where CH340 is connected. On my computer, it's connected to COM3. After checking the USB port, go back to the Arduino program and set it up for the Arduino Uno board. Click on the Tools menu at the top and set the board to Arduino Uno. Then, in the Tools menu, set the port to the port where the Arduino Uno board is connected. Since mine was connected to COM3, I will set it to COM3 and proceed. Now, let's add the downloaded library files. Click on the Sketch menu at the top, then click on Include Library, Add.zip library. Open the compressed file, DHT-zip, that you downloaded. If you see the message, Library added to your libraries, please do the same for the other 2 library files. Finally, we could upload the source code for the Smart Farm to the Arduino. Click the checkmark icon at the top to compile the code, then click the Upload button on the right to upload the code to the Arduino. When the message, Done Uploading, appears at the bottom, it means that the source code has been successfully saved. If the save is complete, please exit the program and disconnect the USB cable. Now, connect the Arduino to the power and check if the Smart Farm is working properly. Check if the plant growth LED lights up when the brightness decreases using the light sensor, and if the LCD module shows a change in the value when the soil moisture changes. You have assembled your own smart farm by connecting Arduino and sensors, combining agriculture and IT technology. Try growing plants using the completed smart farm and connect more smart farms with kit components to create your own farm system. Then, see you next time.